Good day once more. Now we are doing question number 3. Question number 3 of September 2023. So we are doing September 2023, question number 3, which is vertical projectile motion. Okay, don't forget to subscribe, don't forget to share, like and comment. Thank you. Let's start the question. A group of learners set up an experiment to determine the height age of their school. They release a tennis ball from point A, as you can see here, at the edge of the roof of the building, as shown in the diagram below. Point B is 2 meters above the ground. Point B is 2 meters above the ground. That is 2 meters above the ground, and the ball takes 0.125 seconds to cover the distance from point B to the ground, that is C, which means we have the time here, which is 0.125 seconds. Okay, now let's work on it. Then they say ignore the effects of the air friction, meaning that this tennis ball is on free fall. This tennis ball is on free fall. Okay, is on free fall. Write down the magnitude of the rate of change in velocity. So the rate of change in velocity is the definition for the acceleration. This is the definition for the acceleration, which means we are looking for the acceleration of the tennis ball if we ignore the effect of the air resistance, which means the object is on free fall. Therefore, acceleration is 9.8 meters per square second, and then it's always downwards. Okay, so this is 9.8 meters per second downwards. The question is answered. Then the following question says calculate the number 1, the height age. Okay, so we are looking for height age. When we calculate height age, we calculate the displacement, which means we need this displacement, that is delta y, because we already have 2 meters in this path, so we need dy there. Okay, which means let's collect the data. We don't have the velocity here. Okay, which means let's go back to the statement and see what the group of learners set up an experiment to determine the height of the school. They release the tennis ball, which means the velocity here is equal to 0. So the velocity here is equal to 0 meters per second. Then we need the velocity here, which means we are going to use this 2 meters to calculate the velocity here. Okay, at B. Let's start with this one. Let's calculate. We are given the displacement, which is equal to 2 meters downwards. We are looking for the velocity there, which is the initial velocity of that path. Initial velocity of this path, 2 meters. We are looking for that initial velocity. Then we are given the time there, which is 0.125 seconds. Then we know that the acceleration is 9.8 meters per second per square second downwards. Now if you can look at the arrows here, this one is downward and this one is downward, which means we can say take down as positive. Let's take down. Take downwards as positive, which means this one is going to be positive and this one is going to be positive. Then the formula that will go with this data is the one that says final velocity is one that says delta y is initial velocity delta t plus half of a delta t squared. Okay, now let's substitute. Dy is 2. Dy is 2, sorry. So we have 2, which is positive. Then initial velocity is what we are looking for. Then the time, it's 0,125 plus the half of acceleration is 9.8 times delta t, it's 0,125 square. There is this square here. Then we press the calculator here. Then we get here 0,076666. Then here we have these 2. Then here we have 0,125 v initial. Okay, now we need to transpose this one to this side. It will change sign. Then it's 2 minus 0,076. Then we get 1,92, which is equal to 0,125 v initial. Then we divide by 0,125 both sides, 0,125. Then then initial velocity is equal to divided by 0,125. Then the initial velocity there is 15,39 meters per second downwards, which means we have the velocity here which is 15, here which is 15,39 meters per second, but we are looking for dy. Then after dy we calculate the height. Okay, now we have the initial velocity, now we have this final velocity, then we can get dy there. Now let's go the data. We have the initial velocity in that path, which is 0. Then we have the final velocity, which is this one. This initial velocity becomes the final velocity. Final velocity then is downwards. Then we are looking for dy. Then we have the acceleration, which is 9,8 downwards. Then we take down as positive. So we use final velocity square is equal to the initial velocity square plus 2a delta y. Let's substitute the final velocity. This one should be positive and this one should be positive. Then final velocity is 15,39 square, which is initial velocity, which is 0 plus 2 times 9,8 delta y. Then we get 15,39 square, which is equal to, here it's 19,6 delta y. Then we divide by 19,6 both sides. Therefore dy is equal to, let's press the calculator, we get 12,084 meters down. Since it is positive, that is downwards. Then the question says calculate height. Height will be equal to 12,084 plus that 2. Then you get 14,084 meters as the height, Let's go back to the diagram. So the height is covered by AB plus BC. Then we know this one is 2 meters. So that is why we add that 2 meters. Then we get the height. Let's go to the second question. The second question says, calculate the time it takes for the ball to reach the ground. Calculate the time it takes for the ball to reach the ground. We have two options. We can use to reach the ground from here, which means we are going to calculate the time it takes to reach B. Then we add 0.12 because this is the time 0.12. We need delta t in this path. Then we add this one, or we can say we can use the height, that is the height to the final velocity, to the final path, which is c, that is height. Then we get t. Either way, now let's use one of the two. Let's just collect the data and see. So the data that we have in this question, which is question number 3.2.2. 3.2.2. This one was 3.2.1. Then this one is 3.2.2. Okay, where is it? Okay, so let's write it here. So it's 3.2.2. We're looking for the time it takes to cover this height from the top to the ground, which means we have delta y, which is 14,084 downwards. We are looking for the time. Then it was released, the initial velocity is 0. Then acceleration is equal to 9,8 downwards. Since this one is downward and this one is downward, then this one is positive. Also this one is positive. Now the formula that we can use, delta y is equal to initial velocity delta t plus 1 over 2a delta t squared. So delta y is 14,084, which is equal to the initial velocity 0 times the time is what we're looking for, plus 1 over 2 times 9,8 delta t squared. Then we have 14,084. Then this one is 0. Then here is 4,9 delta t squared. Then we divide by 4,9 both sides. 4,9 both sides. We get t squared, which is equal to, so we have 14,084 divided by 4,9. Then we get 2,87. Then the square root to cancel this square. Then with positive, negative, plus or minus. This one, since it's square, you cancel square by square root. Then we get delta t, which is plus or minus. Press calculator. Then we get 1,695. Then since the time is always positive, therefore delta t is positive 1,695 seconds. Then we're done. That is the time. Or alternatively, we can calculate the time from A to B. Can calculate the time from A to B. Then we add 0.125. Let's do that. From A to B, what we have is the initial velocity, which is equal to 0. A to B, that is AP, the time there. We are given we're looking for delta T, then the initial velocity is 0 there. Then the final velocity is 15, what was the final 15,39, 15,39 downwards. Then acceleration is 9,8 meters per square second downwards. Therefore, this one must be positive and this one must be positive. We can use final velocity is equal to initial velocity A delta T. Then the final velocity is 15,39, which is equal to 0 plus 9,8 acceleration delta T. Then we can divide by 9,83, 9,8, I mean 9,8. Then here it's 0. Then delta T is equal to 15,39 divided by 9,8, 9,8. Then we get 1,57. That is the time from A to B. Therefore, the total time will be equal to 1,57 plus 0,125. Then we get 0,125. We get 1,695 seconds, which is the same as this one. Okay, so we have two options here. Let's go to the next question. The following question says calculate the velocity with which the ball strikes the ground. We want to know the velocity at C. We want to know the velocity at C. We know the velocity at B. We know the displacement. We know the time. We can use either the displacement, time, initial velocity, final velocity. Okay, now let's collect the data. Okay, the data for that question, which is question number, let's check. Let's go back. This is question number 3.2.3. 3.2.3. Let's start with the data. We are looking for the final velocity. We have displacement, which is 2 meters downwards. Then we have the initial velocity there at B. The initial velocity is 15,39. The velocity here at B, because the focus now is on BC, so the velocity at B is 15,39. That is our initial velocity, 15,39. So the initial velocity is 15,39 and it's downwards. Then we also have the time there, which is 0,125 seconds. So the formula that we can use is the one which says final velocity square, not that one. Based on the data, we can use the formula which says delta y is equal to final velocity plus initial velocity divided by 2. Everything is multiplied by t. So the delta y is 2. The final velocity is what we are looking for. Then the initial velocity is 15,39 divided by 2 times the time is 0,125. Okay, Then what we can do is to divide by 0,125 both sides. 0,125, this cancels that. Let's press calculator. 0,125 there. Then we get here 16, which is equal to final velocity plus 15,39. Everything is divided by 2. We can get rid of this 2, multiply by 2 both sides, multiply by 2. Then here we have 32, which is equal to the final velocity plus 15,39. Then we can transpose 15,39. We have 32 minus 15,39. Then we get the answer, which is 16,61. That is the final velocity. Therefore, the velocity at C is equal to 16,61 meters per second downwards. Then we answered that question. Then the last question says, sketch the position versus time graph for the motion of the ball from the moment it was released until it strikes the ground. Use the ground as a 0 reference point. So it is very easy. Now that we have, I'll just draw the new diagram there. Here we have the building. This is the building. Then we have the ground here. This is the ground. So they say this one must be the 0 reference, which means if we draw the Cartesian way, we will have something like this. This is supposed to be our 0. On the x-axis is time, which means our graph will be like this. The position time graph is a curve graph, which means let's draw the graph. Here is delta y, or position. Let's just say position of the ball. Here it's a position in meters here. Then on the x-axis we have the time. Then this is position time graph. Now you just copy that one, so which means our graph will be like this. Then here we have 0. Then we need the time it takes from here to here. The time is already calculated. The time was 1, this is the time we're looking for, 1,695. So we'll just write 1,695 here. Then the height here, that is the height. Total distance, it's 14. This is the height of the building, 14,08, which means we write the height here. Here 14,08. Then the graph is done. Thank you for watching the video. Please share and subscribe. Don't forget to like and comment on the comment section. Please follow me on Facebook. Look on M Sciences. Thank you very much.